Hi guys, welcome back to In Case of Econ Struggles. Today we're continuing to talk about causal inference and causal methods. Specifically, we are going to introduce potential outcome notation. Potential outcome notation is super important in terms of thinking about what effect we're actually estimating, in terms of who we are estimating an effect for, so that when we're talking about our results, we're really clear on those concepts. So we'll talk about things like average treatment effect on the treated, and selection bias. Timestamps are below if you would like to jump around, but let's go ahead and get right into it. As a first example, let's think about Bill. Bill is sitting there. Bill wants to know what is the effect of owning a cat on stress level. So if we were to take this idea and sort of turn it into math, maybe we'll say that having a cat is our treatment variable or our x, and that's going to be binary, so 1 if you have a cat, 0 if you don't. Stress level is going to be our outcome or our y variable. Maybe we'll measure that on a scale from 0 to 10. And so we know that x and y could be correlated for a number of different reasons, and we want to know the causal impact of x on y. Where potential outcomes come into this picture is that if I knew my stress level if I owned a cat and I knew my stress level if I did not own a cat, I could simply take the difference between those two numbers and figure out my personal effect on my stress level of owning a cat. So here is me. This is Milo. It's a great drawing of Milo. Let's say that in the real world, since I own a cat, since I own Milo, my stress level is about a 2. So we would say that my outcome, if I'm treated, my stress level, given that I own a cat, is 2. Now there's also a hypothetical version of me, and that hypothetical version of me does not own a cat. If you asked hypothetical me how stressed he is, he would say that probably he's a 7, so his outcome, if not treated, or his y of 0, is equal to 7. So you could see that, well, if my real version has a stress level of 2, my hypothetical version has a stress level of 7, you would say that for me, the effect of owning a cat would be to reduce my stress level by 5, because the difference between 2 and 7 is minus 5. Just to make sure we're clear, here's Bill. I gave Bill a fun haircut. So Bill, in reality, does not own a cat. So if you asked Bill what his stress level is, he might say it's a 6. So his outcome, if he's not treated, his y0 is 6. Now, there is a hypothetical version of Bill, but in this version, hypothetical Bill does own a cat. He does have a Milo of his own, and if you asked hypothetical Bill how stressed he was, he would tell you that maybe he's a 7. And so his outcome, if he was treated, or his y1, would be 7. So the effect to Bill of owning a cat would be 7 minus 6, which would be 1. So Bill would be more stressed if he had a cat versus in the real world where he doesn't. So, maybe Bill's allergic to cats, and so that if he did have a cat, he would be worried all the time about sneezing or trying to make sure his house had as little hair as possible. So that is why Bill does not have a cat. You'll notice that in both of these examples that Bill and I both had a y1 and a y0. We both had a potential outcome for when we had a cat and when we did not have a cat. We both had a potential outcome when we were treated and when we were not treated. So just like Bill has a height, a weight of 0 pounds, and a given eye color, given that he's drawn on an iPad screen, Bill has both a y1 and a y0. It's just a part of him. We say that your potential outcome is sort of like an attribute about you, and everyone has a potential outcome both if they're treated and if they're not treated. You can imagine that if our treatment was not binary, if it ran from like 0 to 10, then Bill would have a y0, a y1, a y2, a y3, all the way to a y10, and those may or may not be different, but the important part is that he has a potential outcome for each value of the treatment. And as we said before, the treatment effect, I'm just going to take Bill's y1, subtract his y0, or my y1 and my y0. You take the difference, and you will get the effect of owning a cat on stress for any given person. Let's sort of beef this up a little bit. Let's add 2 more people. Let's add Deborah and Christy just to make sure we're clear. And what I want to clarify in this example here is that when you get data, you will not know everyone's y1 and your y0. So for example, in our basic example, Bill, we said, does not have a cat. So I'll put that number in green. This red number 7, this is Bill's stress level if he did own a cat, but we know for sure he did not own a cat. So this is something that is inherent to Bill, but we would not see in the data. On the other hand, if you look at someone like Deborah, Deborah's 2 is in green because we observe that she has a cat. So when you ask Deborah her stress level and she says 2, that is the real world. She really has a stress level of 2. And this 5 is the hypothetical world in which Deborah did not have a cat. So her treatment effect, if we could observe everything, would be that having a cat reduced her stress by 3. Christy is similar to Bill. Her y1 is red, which means we did not observe a world in which Christy has a cat. Instead, we only observe the world in which Christy does not have a cat where her stress level is 8, but maybe if she did have a cat, it would help her a lot, and her treatment effect, or Christy's effect of owning a cat on her stress level would be -4. So if I am given this same data, we could take my expected value, or the average, of the stress for people who do have a cat, minus the stress level of people who do not have a cat, and we could compare them and get an average treatment effect of -2, given that we knew everything, their Y1s and their Y0s for everyone. We just calculate each person's treatment effect and we take the average. Now what I want to start going towards is the fact that we don't necessarily have all the data. So let's just do a new example. Let's do anxiety medicine. Again, 1 or 0. 1 if you take the pill, 0 if you don't, on anxiety, and we'll again measure anxiety from 0 to 10. So just to make sure we're clear on how this table works, Barb does take the anxiety medicine, so her Y0 is hypothetical, and that's why it's in red. And Riley does not take the anxiety medicine, that's why her Y1 is red. She does not take the pill, so her Y0 of 3 is in green. We would really like to be able to say that the average treatment effect among these 3 people of the anxiety medicine is -10/3, but that requires us to know everything about every person, including their Y1 and their Y0. And in the actual data, you're never going to get that. You're only going to see these numbers in green. So what are we actually estimating? Well, what you're actually going to estimate is you are going to take the average Y1s among people who took the anxiety medicine, and you're going to subtract the average Y0s of the people who did not. So you're just going to take this 2 and the 4, and you're going to take this 3. So notice that if I just do a quick look at these numbers, you're going to get an average treatment effect of 0 if you do it that way, right? So that's what we call a difference in means. You're taking the average of people who were treated, and you're subtracting the average of people who were not treated. So we are going to introduce a couple different concepts to show why this 0 number could be happening. We're going to introduce something called the average treatment effect on the treated and the selection bias. The important thing here is that the way I got the ATT and the SB is I just took what we actually estimate and I add and subtract these numbers. And so all I'm doing is subtracting and adding the same thing to get the difference in means that we're actually calculating. Let's unpack this math a little bit. So we know that the reason we get to this difference in means is because we only see treated people's Y1s and we only see the non-treated or the control people's Y0s. And there are 2 things that could be affecting what we get in terms of that difference. So when you add and subtract, this is the first thing you get. This is the average treatment effect on the treated. Why is it the average treatment effect on the treated? Well, notice that we're taking YI1, YI0, but both of these things are conditional on being treated or taking the anxiety medicine. So I can just put these together like this, and you can see that this right here is an average treatment effect. Who is it the average treatment effect for? It's the average treatment effect among people who had an XI equal to 1. Who are the people who have an XI equal to 1? Those are the treated people. Now, we also have this selection bias, which is yi of 0 given xi is 1 minus the expected value or the average of yi0 given xi equals 0. So notice that this is the hypothetical version of people who were treated had they not taken the pill. This is the actual people who did not take the pill. And what we're saying is well, how different are Barb and Evan from Riley if no one took the treatment? So how different are the treatment and the control groups just in terms of their Y0? Now you'll notice that, again, we cannot necessarily observe this in the data, but the reason I'm writing this out is because you'll see that even though we got a treatment effect of 0 when we took the average of this 2 and 4 and subtracted the average of 3, how are we getting that? Because obviously this pill looks like it's effective. Look how much it reduced Barb and Evan's anxiety. And I'm trying to show you why we could be getting that 0 as a result. Or this number being equal to 0 could be happening, and we could be underestimating the true treatment effect is because of selection bias. So notice that Barb and Evan are really stressed. Their average stress level, their average Y0 given they're treated, is a 7. Riley, on the other hand, has a YI0 of 3. She is much less stressed than the treatment people, which makes a lot of sense. Why in Barb and Evan taking the anxiety medicine and Riley's not? It's probably because Barb and Evan are more anxious to begin with. So this selection bias is giving us a selection bias of 4. And you notice that for Barb and Evan, their treatment effect was 4. So you can see that we're sort of canceling out the actual effect because of the fact that Barb and Evan were so much more stressed than Riley to begin with. So let's just take those same concepts, plug in some numbers, and see what we get. So we know that the difference in means is 0 because I just take this 2 and this 4, average them together, and subtract the yi zeros of the control people, which is 3, and I get 0. But we also know that if we knew everything about everyone, we would get an average treatment effect of minus 10 over 3. So first, we can take the average treatment effect among the treated, which is just going to be among Barb and Evan. And you can see that their average treatment effect is minus 4. We also said earlier that the selection bias was also equal to 4. Barb and Evan are roughly 4 points higher in terms of their stress than Riley. So the selection bias actually canceled out the entire average treatment effect on the treated. And that is why we are getting an estimate in the difference in means of 0, even though the average treatment effect is minus 10 over 3. So these are the different concepts. We'll talk about them more in the next video, but hopefully this gives you a brief introduction to potential outcome notation and you feel more comfortable with it. If this was helpful, make sure to like and subscribe, and we'll see you next time for another case of econ struggles.